We're in Rosen Discrete Mathematics and its Applications, section 2.3 on functions, and we are going to learn about functions, various types of them, and when we can tell whether a function is invertible. The first type of function we will discuss is called an injection. Another word for an injection is a function that is one-to-one. And a function is considered to be one-to-one if and only if whenever fa is equal to fb, that means a is equal to b. One of the ways to think about that is that the function assigns a unique image to every element in the domain. No two different elements have the same image under the function. Here, our from set A, every element is mapped to a unique element in B, and even though we have an element in B we don't map to, this is still an injective function. All right, another type of function that we will encounter is called a surjection. Another name for that is a function that is onto. And an onto function has the situation is that every element in the codomain is an image of some element in the domain. So for every B in the set B in the codomain, there's an A in the domain that is its preimage. And here is an example. I've got my from set, my to set is B, my codomain is B. You can see that every element in B has a preimage in A. X has a preimage of C, Y has a preimage of B, and Z has two preimages, or a set of two. Okay. All right, and a bijection is a function that is both one-to-one and onto. And another name for a bijection is a one-to-one correspondence. So be careful not to confuse that with a function merely being one-to-one. And our example here is a function that has from set A to set B, and we see that every element A has a unique image in B under the function, and every element of B has a preimage in A. So it is one-to-one and it is onto. All right, so how do we show a function is one-to-one or onto? Some strategies. We'll basically use the definition. To show that a function is one-to-one, we'll show that if f of x equals f of y for arbitrary values, arbitrary elements of A, then x and y must really be the same element. We'll see an example of that in a minute. And to show that it's not injective, we will find a counterexample. Find x and y such that they're not equal in A, such that they have the same image under the function. And then for a surjection, for an onto function, we want to show that an arbitrary element in the codomain has a preimage in the domain. And to show a function is not surjective, you will want to find an element in the codomain that does not have an element, that does not have a preimage in the domain. All right, let's look at some examples. All right, here we have a very simple function from the set ABCD to the set 1, 2, 3, defined as shown. F of A is 3, F of B is 2, F of C is 1, and F of D is 3. Is that an onto function? Well, yes, it is, because I have all of my elements in my codomain have a preimage in the domain. And then, but if I add an element to the codomain, this 4, then f would not, it would still be a function, but it would not be an onto function because 4 does not have a pre-image. How about the function f of x equal x squared from and to the set of integers? Is it onto? It's not onto because we can find a counterexample. -1, for instance, has no pre-image under the function f of x equal x squared, where the domain and codomain are integers. All right, let's talk about inverses. If you have a bijection, and you must have a bijection, we'll explain why in a second. If you have a bijection, a one-to-one correspondence from A to B, then the inverse function is denoted f with this superscript -1 is the function b to a, such that f inverse of y is equal to x if and only if f of x equals to y. And we've basically taken that earlier illustration that if f of a is b, then f inverse of b is just going to be a. And f maps a to b, then its inverse will map b to a. So no inverse exists unless f is a bijection. Why is that? Well, the reason for that is a bijection ensures that f inverse has a domain. This is the domain of f inverse. And remember, a domain has to have every element acted on by the function. And with a bijection, we ensure that f inverse has a domain. And then it also ensures that every element of the domain has an image under the inverse. So the onto nature ensures there's a domain. The one-to-one nature ensures that every element of the domain of the inverse has an image. And with functions like this, images are very easy to construct. Here's my function, here's my inverse, and note that all we did was we turned the arrows around to get the inverse function. And essentially that's what we do for all of them. Sometimes we're able to do it by some mathematical steps. Here's another one, and it look very similar to the one before. A function ABC goes from ABC to 1, 2, 3 is given. Is f invertible? And if so, what is its inverse? Well, we can check quickly to see that it is onto. It is also one-to-one. So since it is one-to-one and onto, it will have an inverse. What is that inverse? Well, f of -1, f of inverse of 1 will equal c. F inverse of 2 will equal a, and f inverse of 3 will equal b. All we did was reverse the arrows, essentially. Now here's I think a more step-by-step test for a general application whenever you see a mathematical definition of the function. But we'll use the same two approaches. We'll check one-to-one, and then we'll check onto. And then after we're done checking both of those, particularly the onto, we'll be able to write down what the inverse is. First, let's check one-to-one. So we'll use the definition. Show that f of x equal f of y implies x equal y. Well, let's start with the hypothesis there. F of x equals f of y. I'll substitute. In both cases, that's x plus 1, and then the other one is y plus 1. And then I solve, and I show that, indeed, x equals y. So I get the green check mark, says I've made sure that the function is one-to-one. To show that it's an inverse, I also have to show that it is onto. And remember, for onto, we need to find a pre-image for every element in the codomain. Well, the codomain is integers. and I need to find a preimage in the integers. So for every y in the codomain, I've got to find a x in the domain such that f of x equals y. The way I do that is I assume y, and then I try to find the x. So f of x equals x plus 1 equals y. And that means what I do then is I got to find an x that gives me that y. Well, here it is. I just solve for x. And x is equal to y minus 1. Well, y is an integer, so y minus 1 is an integer. And so I get the green check boxes. Yes, I have found an x for every y in the codomain that is in the domain. The other nice thing about showing onto is it actually gives us the inverse. So the inverse is a function in y, and it gives us x. It's y minus 1. So it's invertible because it's a one-to-one correspondence, that is both one-to-one and onto, and I get the inverse is the result of the check for onto. All right, let's look at one that doesn't work. Example 3. Is f of x equal x squared invertible? And if so, what is its inverse? Well, the first thing we do is check one-to-one, and we'll note that we will find a counterexample to this. I have f of negative 1 equals 1, which is also equal to f of 1, but negative 1 doesn't equal 1, so I fail the one-to-one check. And since I failed the one-to-one check, I cannot be invertible because I'm not a one-to-one correspondence. And that's a discussion of injection, surjection, bijection, and invertibility.